we are continuing in section 1.8, the graphs of f and f inverse. The graph of f inverse is a reflection of the graph of x about the line y equals x. So I mentioned this in the previous video, and I mentioned that y equals x is called the identity function. The two sides are equal. And this graph looks like this. Our input-output table, if you have -2 and x, it produces -2 and y. It's the identity, all the points are equal to each other. So if you were to graph them on an xy plane, it would look like this. So something like this. And if I connect those points, my graph is going to go, it's like the diagonal through the origin. And so when you graph, and we took a look at this, when you graph two inverse functions, the inverses, they have a reflection about the line y equals x. So you could fold it on this line and they would match up. The two inverses would match up. It would be like a mirror image of each other. So we're going to use that information to help us graph the following. So here is a graph of function f. We're not told the equation of the function, we're just told that this is function f. So pause the video and write, there are 3 ordered pairs here that are marked. So write those ordered pairs, kind of label them. So once you are done with that, unpause the video and make sure that your ordered pairs match mine. All right, so now that you've unpaused the video, this would be -3 on the x, -2 on the y. This would be -2 on the x, but then you have to go up to +2 on the y. And this last one that's marked here, this point would be 4 on the x, but +1 on the y. So we have these 3 points. So I am going to write that function f of x has this input-output table. And you can call it xy, you can call it x f of x, and I'm going to put those ordered pairs in this table. Now, what we were talking about in the previous video is that when you have inverses, their domain and ranges are swapped. So if this is the function and I want to graph the inverse of it, so f inverse x, then all I need to do is take these ordered pairs and swap them. So the domain would become the range, and the range will become the domain. So I just swap the x's and the y's. And then I'm going to graph these, and I'll use this graph paper that's provided for me. I'm going to plot those points. So -2, -3 would be down here. +2, -2 would be here. And then 1, 4 would be up here. And then I'm going to connect those points, and I get something that looks like this. And then just to help us visualize this, I'm going to plot the points that we started with. So -3, -2. And then I've got -2, +2. And then I have 4, 1. and I'll connect those points so that I have them both on the same xy plane and I can look at them better. So now I see this. And so I've taken function f of x using the ordered pairs that I could read from the graph. I have now graphed the inverse function. And if you look at the last page, they have graphed both of them for us also on the same xy plane, and they have drawn in that line, that identity function. This is the line y equals x. They've drawn that in so that we can see how the two kind of are a mirror image about that line. These are inverses of each other. And that is the end of 1.8.